decreases, the mean advertised price. So when we're getting these y-hats, the y-hat is an average of many cars, and that will affect our interpretation of it. Okay. And we'll talk more about that as we proceed. Next is the intercept, represented again by A. So how would you interpret this? So what it means is this is the expected value, or the average of the response. So in our case, the intercept is the average advertised price when the explanatory variable is 0. That's what the y-intercept means. Where does the line cross the y-axis? Well, the y-axis begins when x is 0. But x means something. That's a variable. In this case, the age. So when the age of a car is 0, A is going to be its average advertised price, because that's where this line, the y-hats, cross the y-axis. So the intercept is an average specifically when x is 0. Again, its value will be computed by StatCrunch, and it has an interpretation. So this is kind of a template that you can follow, like we have for confidence intervals and the hypothesis tests. But we'll do an example of that. Slope. So on Thursday, several of you referred to this as rise over run, which is, yeah, you can still do that. So what that means is the slope is telling you how the line changes. As you run some units, how does it rise or fall? That's what the slope is all about. So what it's telling us is what's the change in the response as the explanatory variable increases by 1 unit, whatever the units are. Okay. Now it has another template here that I've provided for you, and we have to be very careful in how we interpret this slope. So we'll do an example again, but what you might notice is that there are some key words that are necessary to include. So we have the word associated as well as on average. So the on average is because, again, we're talking about the line, which represents all of the y-hats, which are averages. So the slope is telling us what the average change is. The associated aspect is because we don't want to say something like, for example, as a used Toyota Corolla gets 1 year older, its price will go down by $1,000. We can't say that because that sounds causal. It sounds like there's a causal relationship between age and price. And we don't know that. All that we know is that there's an association. There's a pattern. There's some type of correlation. So we don't want to interpret the slope and make it sound causal. So that's why we're saying we're seeing a change, but that's due to this association, not a causal thing. Within the best fit line, the X you see, you plug that in. You decide what X you want to make a prediction for. What value of the explanatory variable. So in this case, age. So if we want to predict what the advertised price will be for a 2-year-old car, then X would be 2. So we just plug that into the best fit line for the X. And again, we have the residual. So its formula is y minus y hat. So if you remember from the coordinates of the example we did, the x's are the same. So x is the horizontal distance between 2 points. Well, they're at the same x value. So the difference between the x's is 0. So the residual simplifies to just the vertical distance. So that's y, the observed data points value, minus y hat, the predicted value. So that's why if the point is above the line, that difference will be positive. If it's below the line, that difference will be negative. And we'll do, again, some examples of computing residuals. Okay. So some theory just to keep in mind. In this example, I think we have like 15 cars. And what we're imagining is there's a population of a lot more used Toyota Corollas. And if we had all of those cars with all of their ages and all of their advertised prices, we could plot those out, and there is some true line that would fit all of the data. So conceptually, what we're kind of doing now is we're estimating not a point or a value like a mean or a proportion. Now what we're trying to estimate is a line. So it's kind of an odd thing to estimate, but that's the idea. There's a true line that exists. We don't know exactly what it looks like, meaning we don't exactly know its true slope and true intercept, but we want to estimate that line. So our statistic will be a best fit line from a sample of data. And it has a sample slope, or an estimated slope, and an estimated intercept. So the true model is something like this. The true intercept is alpha, so not the level of significance. Again, kind of confusing. Here alpha is the true intercept. The true slope is beta. So we estimate beta with B. And there's this weird plus epsilon piece. You don't have to worry too much about this. It's just saying that there's going to be variability at every age, and that variability comes from a normal distribution. And we've talked about that. So if you want to do regression in StatCrunch, which you should definitely try it before Thursday, you can use the, the student data sheet. Pick two quantitative continuous variables, say miles from campus and minutes from campus, and you can create a simple linear regression line. See if it makes sense to do it, run it through StatCrunch, and see what you get. So it's pretty simple to do. You'll get some output, and we'll discuss that output next. So before we look at the output, we have to understand that linear regression is an inferential process. We have a sample. We're trying to use that information in the best way we can to learn about the population. So we're going to be making some assumptions. And they're probably not that surprising. So the first one is, I don't know, maybe overly complex. So it says the mean of the response changes for different values of the explanatory variable, specifically in a linear fashion. So all of this is really saying is there's a trend, there's an association. Something is happening between the points. It's going up or it's going down. But specifically, it looks like a straight line. So we can't do regression on curves or anything more complex than just a straight line. You can, but not in this class. We'll take some more classes. The second point, unexpected, is to ensure that the data were gathered randomly. So we always need that. And the third point's kind of an odd one. So I'm presenting it to you. Don't worry about knowing it. But it is something to keep in mind. So what it says is that the values of the response variable are following a normal distribution at every x. And all of those normal distributions have the same variance or standard deviation, but what's changing is the mean. So that was this illustration that we did on page 4. For every x, for every explanatory variable, all of the responses that are there and would be there are coming from a normal distribution. And that's true at every single x, but they're all the same normal distribution in terms of shape. All that's changing is the mean at that point. Okay, so those are the assumptions. Generally they will all be true. Really the ones to check are the first two. If if you don't know or you're unsure about this normality assumption, don't worry too much about it. There are ways to adjust for it and to fix it, but that's beyond this class. So just make sure you have random data and that there is some type of association. Otherwise, there's nothing to learn about. So here's the output you will get from StatCrunch, and it's sort of three pieces. So we have this first set of stuff at the top. We have this table called parameter estimates, and then we have this table called analysis of variance. This third one we don't need. We'll come back to it later. It has good information in it, but we don't need it right now. Most of what you need is in this first piece. This has a lot of the primary information. The parameter estimates is also useful because, as you may notice, there are p-values. So that means there are some hypotheses being tested, and we'll talk about this. So the first thing you would want to know is, okay, here's my output. Well, what's the equation for that best fit line? So that line from page 4. What is its equation? Well, you get that from up here. So what StatCrunch tells you is that the price is equal to some function of age. So you have a number by itself, and then you have a number being multiplied by age. So this number being multiplied by age, there's your slope. The number that's all by itself, there's your intercept. So we call the intercept A, and we call the slope B. So in this case, the intercept is 14,285. The slope is negative 959. So if we wanted to write out what that equation was, oops, sorry for bumping the camera all over. It's kind of difficult to write and keep the camera nearby. So the equation would look something like y hat, so that's the predicted advertised price, is going to be equal to 14,285.95, so a little over $14,000, minus $959.05, we'll say, times age. Okay. Now what I don't like about the StatCrunch output is they're telling you, okay, here's the advertised price. But in fact, there should be a little hat above this because it's a predicted price, an average predicted price. Okay, so there's the equation. So we can see that the slope is negative, as we expected, because there's a negative association. And the y-intercept was pretty high, around 14,000. So that, again, makes sense if we look at the scatter plot on page 4. As we run along the x-axis, the rise is actually a fall. So the line's going down, so the slope should be negative. And then the y-intercept, again, kind of hard to see because these axes don't start at 0. It starts at 1 and almost 2,000. But if you follow this line up until it crossed the y-intercept, it would happen a little over 14,000. So what do we do with this line? Well, we can do a couple of things. First, we can interpret and explain the intercept. So what was the value? The value of A was, again, the 14,285 and 95 cents. Okay, so the intercept, again, is always the number in the equation that's all by itself. It's not being multiplied by anything. That's the intercept. So if we wanted to interpret this, we would say something like the average advertised price, that's what the response is here, is $14,285.95 when X is 0. So X is the age. So when a used Toyota Corolla is 0 years old, or is brand new. Okay, so that's what the intercept's telling us. If we had a brand new used Toyota Corolla, think about that for a second, then we would expect its advertised price to be a little over $14,000. So then the question is, should we have interpreted the intercept here? You can always find a value, that's fine, but the question is there a reasonable interpretation for it? Does it make sense to interpret it? Why or why not? So in this case, we should not have interpreted the intercept. It doesn't make sense here. So as we just explained, we're saying this is the expected price for a brand new used Toyota Corolla. Well, that doesn't make any sense.